About a year ago on Morse Code of Weather, I talked about the basics of lightning. Today we're going to revisit some of those basics, but go more in depth into some lightning-related phenomena. But first with that, how lightning works. You have the sun that's heating the ground during the day. In the summertime, there's enough heat to form convection. We first get just fair weather cumulus clouds, but eventually on a day when there's enough instability or enough rising air and enough moisture in the atmosphere, we can get those clouds to billow a lot bigger, form cumulonimbus thunderstorm clouds. And within those thunderstorm clouds, we have ice particles, we have graupel, which is kind of compacted snow particles, and raindrops. And all of those are colliding with each other, and they're forming charged particles, positive and negative charges. Usually the positive charges go to the top of those cumulonimbus clouds, and the negative charges sink down to the bottom of the clouds, closer to where the rain is exiting, and usually have the ground that's positively charged. Now, if there's excess charges within the cloud, it's going to try to want to discharge some of them, let go of some of those charges, and make a connection with the ground, usually the taller objects on the ground, and we get a negative cloud to ground lightning strike, making that connection with the cloud to the ground. We can also get positive cloud to ground lightning strikes from the top or the anvil of the cloud all the way down to the ground, and intra-cloud lightning flashes within the thunderstorm cloud itself between those positive and negative regions. Some climatology of lightning, of course, it's the most frequent down near the Gulf Coast, where you have prolific thunderstorms almost year-round. Here in North Dakota, we get about 1 to 2 lightning strikes per year for every about third of a mile in the state, for every square kilometer technically. And if you look at a chart, this is going on this axis, the date of the year from January all the way through December, and this is going from the time of day from midnight in the morning hours all the way through the evening. This is when the frequency of lightning usually occurs. And we're going to zoom in here into the summer months, the one that's usually happening the most. And the peak of when we usually see the most lightning here in North Dakota is between June 11th and July 15th, with kind of May 21st to August 26th being a larger range of when our lightning season is. 4 p.m. to 1 a.m., so in the afternoon and evening hours when we have that most daytime heating, and even lingering into the overnight is when we most frequently see lightning, whereas between 9 a.m. and 1 p.m. is where lightning is least frequent. So that's some climatology, but now let's go into some lightning-related phenomena. St. Elmo's fire and red sprites are what we are going to cover here over the next couple of minutes. First with St. Elmo's fire. This was last month prior to Hurricane Idalia making landfall. This was actually part of the Air Force Base refueling squadron planes, and you can see all these flashes of what looked to be lightning, but unlike the cloud-to-ground lightning strikes that we were talking about earlier, and those involved the movement of electrons from the charged cloud to the ground, this is simply sparking. It occurs when there's a significant imbalance in that electrical charge within the atmosphere, and you can get these flashes of blue light that are fairly frequent. There's a lot of them. So you have the friction within the storm clouds producing that excess amount of electrons, and the clouds want to discharge that amount of usually negative charge. So when there's a sharp pointy object, you can have a ship's mast, a cell tower, or the wing of an airplane in that video that we just showed you, that comes into contact with a very high electrical field that has a large number of electrons. So there's a big electrical field around some of these thunderstorm clouds. That tends to concentrate that electrical field in a way that the electrons are pulled from the surrounding air and towards that pointed structure, the cell phone tower, the wing, or the cockpit of an airplane, or a ship's mast. So sailors coined the phenomenon. They called it St. Elmo's fire after the patron saint of sailors. Now focusing on red sprites. This was a photo from the International Space Station. You can see this red dot right here. That is a red sprite above a thunderstorm cloud. Here on Earth, we've had some talented photographers capture these red sprites well above thunderstorm clouds, and they capture them at a distance. This is one of many transient luminous events, TLEs. They're electrical phenomena that occur above thunderstorms and produce brief flashes of light in different colors. We're going to focus on these sprites, but there's also blue jets and elves that are very rare, but you can see them sometimes at night above thunderstorms. But with these red sprites, there's a lot of really interesting ongoing research with how these form and how they can be captured. So they are seen when we have a large but weak discharge of electrons, usually the same time as a powerful lightning strike at the ground. They're rare to see by eye. You usually need a sensitive camera to photograph them. They're only seen at night because they're fairly faint, and they only last less than a second, and they can extend up to 60 miles above our thunderstorm thunderstorm clouds. So there's a lot of ongoing research. What we think they happen is because of a positive lightning strike close to the ground, and those are the stronger variety of lightning strikes compared to negative strikes that are usually over shorter distance. Usually the positive lightning strikes come off the top of the thunderstorm cloud. So we have the positive lightning strike into the negatively charged air, and they're red from the interaction between the charged particles and nitrogen within the atmosphere. So some really interesting but not really well understood lightning phenomena. One final thing here, a lot of people think heat lightning is real. Well, it's actually a myth because many people incorrectly think that heat lightning is a specific type of lightning. It's just simply the light produced by a distant thunderstorm. So whether it be mountains, hills, trees, or just the curvature of the earth, that can prevent you from seeing the actual lightning flash. Instead, the faint flash is just light being reflected off of the higher level clouds, or that anvil, the top of our tall thunderstorm clouds. Also, the sound of thunder can only be heard for about 10 miles from a lightning strike, whereas you can see the flash a lot farther away than 10 miles. So some other interesting lightning-related phenomena and facts to pass along to you. That's Morse Code of Weather for this week. Back to you, Jody and Kevin.
Jacob, always good stuff, right? I mean, we just love to learn about all the things weather. Well over 50 episodes now, but lightning's always fascinating. It's always a hot topic because we all have to be weather aware whenever there are thunderstorms present.